Hey everyone, welcome to this session. So my name is Marimuthu Marasamy. You can call me Mari. I'm going to introduce the JVM backend for Idris 2. So this has been in the works for the past few years now, starting with Idris 1. And it's compiled all the way from Idris 1 to Idris 2 boot. And Bloodwind, and then the current Idris 2. The current version is 0.4.0 for JVM. I'll be soon upgrading to 0.5.0, and this is the GitHub repository, and this is basically Idris 2 compiler with JVM backend as the default code generation as well, and it compiles to Java 8 bytecode. Because still Java 8 is being used widely, so the JVM backend currently it does tail call optimization. I'm going to speak about in detail about that, and also it supports FFI for calling Java methods, constructors, and arrays, for example. All right, so let me start with an example. So this is a simple hello world kind of application. So nothing is different from other backends. So you compile it usually with Idris 2, passing the file name and then an output file, and you can run it with, so that will generate a jar file, and you can run that with JVM as usual. So here a few things. Idris 2 itself is a wrapper script around JVM, meaning Idris 2 compiler is also running on the JVM. And since it's running on the JVM code generation is the default, so you don't have to pass the CG option. It's going to generate main.jar, which will be available in main app folder, similar to other backends. And it also requires the runtime jar as well. That includes some runtime implementation classes for the JVM backend. So let me show quickly what it contains. So the output option that you provide, if you pass main, it's going to generate main.jar, and the jar will contain basically the class files, and the thing is it's going to compile only the used functions. So if you are compiling a very small module, it's not going to compile all the Idris library code. It's going to compile only the functions that are used from the main function. So as you see here, this particular small example, it only makes use of, for example, make monad and make applicative constructors, and then few other modules, IO, main, and primitive IO. So it generates class files only for those modules. And another thing is it's going to split into multiple class files. So basically it goes by Idris module system. So each module will get its own corresponding class, which I'll talk about more, and I'll also show a few examples. So that is the basic functionality. Nothing different. It's just launching the Idris compiler with the JVM backend, and then it's going to produce a jar file with all the class files. Okay, so I want to talk about a few things, how the bytecode is generated from Idris constructs. So here we have few basic types from Idris and how they are transformed into JVM. So nothing, not big surprises here. So all the primitive integer types are compiled to Java int, and then 64-bit is compiled to Java long. And so on. And nat and integer, natural numbers and integers, are compiled to big integer on the Java side. So only notable difference here with default Idris backend, here the int type is actually 32 bits. This is something I found out when I was compiling the compiler for the JVM backend. In the default backend, it's assumed that the integer is I think it's 64 bits. So there were like a couple of places where I had to modify the compiler code to work with 32 bits on the JVM. So that's the only main difference, but other than that, everything else should be consistent with the default backend. Similarly, the higher level constructs like Idris constructors, cases, and functions, they are all compiled into Java classes and methods. So constructors are compiled to named classes. We saw a couple of examples in the hello world example, like we saw make monad and make applicative. They are all named classes. And the case statements are compiled to JVM lookup switch. JVM also supports provides another kind of switch which is a bit more efficient, but it's not handled currently. And also for case statements, there is some special handling for string and natural numbers and integers. This is basically how Java compiler compiles. So if you have a switch case in Java, the Idris backend would also compile to similar bytecode. Only difference is it's not just for string. It uses the same mechanism for compiling the natural number cases or integer cases. And functions are compiled to static methods, and tail recursion, as I mentioned in the beginning, tail calls are optimized. Of course, JVM doesn't support tail calls, so tail recursion is eliminated using a while loop equivalent in the bytecode. It uses JVM goto instruction, which are basically equivalent to Java while loop. And then other tail calls, they are optimized using trampolines. I'll show an example for that. And Idris lambdas are compiled into Java lambdas. So if you are used to Java 8, we have this function interface where you can have Java functions compiled to functional interface. So the Idris JVM backend uses a similar mechanism to compile JVM Idris lambdas to Java lambdas basically. And similarly, the Idris delay construct and zero RT functions, they are compiled to Java lambdas, but only difference is they are memoized. So if you execute the delayed expression or zero RT functions more than once, it's going to return the cached result. I'll show an example for that as well. And then namespaces, as I mentioned in the beginning, they are compiled to Java packages. So which we saw here, as you see here. So the make monad is in prelude interfaces module. So it's compiled to Java packages. So that's basically how the high level transformation works. Now let me show you how tail recursion is handled. So as I mentioned, there are two types of tail calls. You can have a tail recursion, in which case you can simply transform the control to the beginning of the method using JVM goto. This is exactly how while loops are compiled in Java. So this uses the same mechanism as the Java compiler. So here is a simple function sum. As you see, this is tail recursive on the go function. But another thing to note here, the go function call itself is in a tail position, but it's not tail recursion, right? It's just another function call in tail position. As I mentioned, other tail calls, they are optimized using trampolines. So I'll show you how this gets compiled. So this is the decompiled code. So you see here, this is the go function. And in the JVM bytecode, you would see goto, but if you decompile it, it actually transforms into while loop. So the second branch you see here, this is not actually calling the go function itself, but it just replaces the arguments with the new values, and then it goes to the beginning of the loop and it continues the next function invocation. And this also demonstrates the thing I mentioned before about switch cases on integers. For efficiency, switch cases, integer switch cases or natural number switch cases are not compared. The numbers are not compared every time. They are basically hashed, and then the actual comparison takes place after the hashing. So in this case, if the hash code is actually 0, the actual comparison if the number is not 0, the actual comparison is not happening at all. It just goes to the default branch and then it executes the default code. So it's a bit more efficient rather than comparing every natural number against each other. This is exactly how Java compiles string switch cases. So this uses the same mechanism. Okay, so the next thing, while we are talking about tail calls, so this is another example where we do have tail calls, but it's not to the same function. So here they are mutually recursive. So odd calls even, and then even calls odd. Let's see how this gets compiled. So as you see, two functions here, is odd and is even. And the interesting bit here is this one, where the tail call is not actually happening, it just creates a lambda. And then the actual function call would happen when we unwrap the trampolines. So basically this way we don't exhaust the stack, we just create chunks in memory. So we are basically trading off stack for memory. So it's creating chunks, and then at the end in the main function or the caller code where we actually need the value, that's when the unwrapping happens. So this way the stack will not be exhausted. And so this is calling even in a lambda, and similarly this is calling odd in a lambda. Yeah, so let me show you how this actually works. So here is a simple function. I already compiled it and decompiled it. Actually, I extracted the class files, and then if you open, actually maximize this. Right. So if I open the okay, so this is the main class or the main module, and as I said before, the main function itself, since it doesn't have any arguments, it's actually compiled into a memoized lambda. This is the way all the zero arity functions are compiled, and then you basically, when you execute main, you just call evaluate and it will be cached actually. So when you execute evaluate again, it's going to return the same result as I mentioned before. Okay, so now let's if you look at the code, so this is the is even function, and then this is odd, and as you see here, the actual call is not happening, but there is just a lambda, right? And similarly, yeah, this one we saw before, it's compiled into a while loop, and as I mentioned before, the sum function, if you look at it, it actually calls go in a tail position. So similar to the mutual recursive case, even that call is actually compiled to a lambda. So that call itself doesn't happen here, but it will be called in the main function. So that's how it compiles. I also would like to show how we have other classes here. So as I said, only used functions are called. So in this case, we are using quite a few modules, which is different from the initial hello world example we saw. So this is using show module, interfaces, and then types, and you see classes for each of those modules here. So this is one of the constructors, open and prefix minus. So the constructors are compiled into named classes, as I explained in the beginning. And here is the applicative and monad constructors. So the JVM backend, for all the constructors, it automatically generates a toString. It may not be that useful in the Idris code, but if you want to debug something, it will be useful. And then let's take a look at a few modules here. So this is the IO module compiled. So you see this, you see some of the primitive functions, put string and put string line, println. And as I said, only used functions are compiled. So if you don't use some of the functions in the IO module, they will not be compiled into the bytecode. Similarly, show module. So yeah, here is a switch based on Idris constructor. So all the Idris constructors, they have an integer constructor ID. So the switch cases for on constructors, it basically makes use of that. Yeah, and that's pretty much how the tail recursion is handled. And I also showed few examples of how other modules are compiled. Now let's go back here. So on the FFI side, it's still evolving. It's not final yet, but this is what we needed to compile the Idris to code base itself. So basically, it supports calling static methods, instance methods, constructors, and arrays, and few other things. So it doesn't support getting Java fields or setting Java fields yet, but they will be added in the future. So here we have an example of how we can call a Java static method. So this is calling value of function from string class. So you give the function name, and then you give the fully qualified class name. And integer and strings are equivalent to Java integer and strings, so you don't really have to specify the type here. But most of the times you need to give explicit types because Java has overloading, so you need to resolve which method you want to call. So this is an example where we call a function. So value of has many overloaded versions. So here we want to call a specific overloaded version, which is taking a boolean and returning a string. So this one is again a static method call, but this time we are passing explicit types. Similarly, instance methods, only difference is in the method name. If you prefix with in static method case, you just give the method name, but in the instance method case, you give it a prefix with dot. Again, this is all not final yet. Maybe we can have some better mechanism, but currently if you prefix a method name with dot, it's an instance method call. So here I'm using Java regex classes. So this one compiles the regex pattern, and then this one matches, and this one gets the first group. So here we have an example here. So this is a regex pattern, and then I'm compiling that against this string, and when it matches, I'm getting the first group, which would basically print Idris here. So this is how we compile instance methods. Again, same mechanism. You can have explicit types. Most of the times you need to give explicit types. I'm also thinking of improving this. Maybe we can even, since the Idris compiler itself runs on the JVM, we can basically introspect the classes and figure out internally rather than users giving explicit types. So that's an option that maybe we can explore. And it also supports constructor calls. I'll show an example later. So as for performance, as I said, it does optimize few things like cases, tail calls, and a few other things. But here we have a simple example. Again, as with most of the performance tests, this is not really an accurate representation of performance, but it was interesting to see this example. So this is simple. The example we saw before, it's basically a tail recursive function, and we get a number from the command line, and we sum until that number. So I compiled this with as usual with JVM backend, and then we can run it in quite a few ways. We can use the standard JVM, and we can also use Graal VM. So those who are not familiar with Graal VM, it's just another Java virtual machine. It's implemented in Java, but it does provide a lot of optimizations like ahead of time compilation. So you can actually compile your Java code into native code with native image, along with optimizations on top. And yeah, you can run it as a native program. So this particular example I compiled with JVM and Scheme backend, the default backend. JVM, as everyone knows, it has a bit of a start time delay. Again, this is not really a good performance test because it's not considering JVM warm-up time. Maybe if we can use Java micro benchmarking harness, we can get an accurate picture. But as you see here, JVM has startup time, so it's actually taking a bit long time. But GraalVM, on the other hand, it provides faster startup. So you see here, this is actually beating the Scheme default backend. But this is just one example. If you have other programs, maybe if we have trampoline example, I think Scheme would probably perform better, because for every tail call we have a lambda, but on the Scheme side I think it's just direct function call. So on that front, maybe Scheme would compile faster. Yeah, so okay, I'll also show how we can compile to native image. So so GraalVM provides a program called native image. So you basically compile your program as usual, and then you have a jar file. Then you can just pass the jar file to the native image program, and it will produce an executable, native executable actually, which you can run like this. So this is how I tested the GraalVM performance. So yeah, we need to see how we can leverage GraalVM. One of the areas I wanted to leverage GraalVM is for the compiler itself. So the Idris compiler code, again, it itself is a jar file. So we can probably compile that jar file using native image, and we can see how it performs. Currently, the Idris compiler on the JVM backend, it does perform a little bit slower than the Scheme backend. So I want to see how GraalVM performs there. So that would be an exercise interesting to see. Right. So that's on the performance side. Okay, yeah, so I did use this number to sum. I also want to show a quick example where how we can consume JVM libraries, because one of the advantages is JVM has a vast set of libraries. So you want to use, in some cases, maybe Java libraries in your Idris code to do few things. So currently there is no proper plugin support for Idris. Maybe with JVM backend we can implement some, but until then we can still use some generic plugins like exec plugin, which can call any executable. In this case we will be launching Idris compiler itself, and Maven dependency plugin to get the dependencies from Maven and package it along with Idris code. And then app assembler is just another Maven plugin that can generate launcher scripts for your Idris program. So here is a simple program. I'll show how this looks. So this is using a library called JSoup, which is a HTML parser. We can basically scrap HTML from websites or even HTML files, as we see here. So let me show how this works. So as I said, this one is yeah, this is using the library called JSoup. Yeah, basically this one, and it's a simple Idris program with some foreign function calls. It basically parses this presentation itself, and it gets the first page, and it looks for the header 1 element in the HTML, and it prints the title. So on the Maven side, so I'm going to open the POM file. It may be a bit scary because of verbosity. So as I said, it uses the exact plugin to launch the Idris 2 compiler, and we pass the Idris package file, which is also here. So one thing with JVM backend, the foreign function calls, you don't really need to have the libraries on the class path, because the bytecode compiler itself, it doesn't care what class or what method we are calling, it just generates bytecode, right? So when we are compiling Idris, we don't really have to provide the Java libraries in the class path, but of course when you want to run it, you need to have all the libraries in your class path. So that's why this Idris package file and even the Idris code, we don't see any reference to Java libraries, unlike the C backend where you need to provide some C libraries along with your FFI calls. But with JVM bytecode backend, you don't need to do that. But there is a downside to it. If you have wrong FFI calls, you would run into no such method error or no such class errors. So yeah, so this is a package file, and then you have the Maven build file, which is so the compiler is launched with the compile phase, and then after the compilation is done, the dependency plugin will arrange all the libraries into one place. In this case, I have configured it to be here. So you see here the JSoup jar, which is fetched from Maven, and the Idris JVM runtime, which is local, and then the current module itself compiled into a jar file. And then we also want to generate the launcher scripts for Unix and Windows. So the app assembler Maven plugin does that with correct class path. So here you see one executable. This is for Unix systems, and then one for Windows. And you can run it with just Maven install, which will compile Idris and produce the jar files, and the dependency plugin will package everything into one folder, and then the app assembler plugin will generate the launcher scripts. Then you can just basically run it with this. So this is the title in the first page. So we were able to parse the title from the HTML. Right, so you can have multi-modules this way. In fact, the Idris compiler code that I'm working on, it is itself a Maven module. Actually show quickly. So yeah, as you see here, Idris JVM is the repository, and we have few Maven modules here, and they are all packaged like using the mechanism that I mentioned just now. So we have 4 Maven modules along with Idris source code. Yeah. Okay, so okay, while we are talking about Idris JVM code base, I also want to show a few examples of how the Idris library modules are compiled for the JVM backend. So here is one example. We have the clock module in the Idris repository. So we already have scheme and refc foreign specifiers, but in the JVM backend we have added this, which is using the same mechanism I explained before. You pass the method name and the class name at the end, and it will be compiled to the JVM bytecode. So this is for clock module, and similarly you have directory, file, all those modules are added with JVM foreign specifier. So these foreign methods, that's what the JVM runtime module is for. So the runtime jar that you are passing when you are executing the Idris modules. So all these classes are part of the JVM runtime module, runtime jar. Okay. So there are a few things we can still do. So next immediate step would be compiling to 0.5. I was hoping I could get that done before this presentation, but I was just able to wrap 0.4 like yesterday. But yeah, hopefully soon we can have 0.5. There are few foreign function call improvements we can make. One is passing Idris lambdas for Java functions. Idris, Idris 1 JVM backend actually supported this, but I haven't added that yet for Idris 2. So that would be our next step, because this would give some flexibility of introducing Idris into existing Java projects. Similarly, Java annotations. This would be a huge thing, because a lot of Java frameworks, they are annotation based heavily. So if we can annotate our Java in our Idris modules with Java annotations, that would be really helpful to introduce Idris into existing Java projects. Maybe we can have one module on Idris and then another module on Java, and they can all run together on a JVM. Similarly, another thing would be extending Java classes and implementing interfaces in Idris. This would also be hugely helpful to integrate into existing Java projects. And as I said initially, JVM is a big thing. I'm very much interested in this, so I'll be exploring this soon. Yeah, of course, IDE and build tool support. I know we have language server protocol implementations, but hopefully with Idris JVM backend, IDEs like Eclipse or IntelliJ, they can probably use the Idris JVM backend directly to integrate with the compiler very closely, rather than using a server protocol. So let's see how that plays out. And of course, the build tool support, as I said, with Maven and Gradle, native plugins, rather than using exec plugin or assembler plugin. So yeah, they are all, I know I'm missing a lot of things here, but these would be our immediate steps. Big thing would be compiling to 0.5. I'm very much interested in seeing how the common sub-expression elimination works with JVM backend, because that's one of the main thing where some Idris compiler classes, they are actually exceeding JVM class size and method size. Because a lot of expressions are duplicated, and they increase the code size. So in some cases, I actually had to split the Idris class files into multiple. Let me show quickly one of those things. So the example, or actually I can show how the Idris compiler, maybe not. So okay, let me show one of those examples. So yeah, we in some cases we need to split the classes into multiple, and even the lambdas, there may be like too much lambdas in the code, and I have to move some of the lambdas into another class file so that to not increase the class file size. So here is one such example. This main lambda main $0 class, this is yeah, all the functions are synthetic here, so you don't see that here, but since the main class already had a lot of lambdas, and since we don't want to exceed the class size and method size in the bytecode, some functions are compiled into a different class file. So yeah, with Idris 0.5, I hope that improves. So I really want to see how that works out. Maybe we will even see the reduced bytecode size. Yeah, that's, I think, pretty much it. I think we covered everything. Yeah, so any questions? Okay, I see a few questions on the chat. So the tail rec annotation, it's not required actually. So the JVM
it's working. I had a couple of questions in chat.
Yeah, I see the questions now.
I wonder if the audio delay will make this Q&A difficult. I think we should all ask questions in chat rather than out loud.
Yeah, I think there is definitely some delay. Okay, so but I can go through the questions from the chat. So the first question on tail rec annotation, it's not really required though, because the JVM backend actually analyzes the functions, and if it sees a tail recursive function it automatically optimizes those functions, so without explicit annotation. So let me show this example, right? So this example 2, here as you see, you don't really need to provide any annotation here. It just compiles automatically, eliminating the tail call. Same for mutual recursive functions, or any general tail calls. They are optimized using trampolines. And regarding the next question, difference between pointer string and string, not much difference though, because in the JVM world, string is actually an object and pointer is actually compiled to an object. So both are same really. And since we don't have any pointers in JVM world, pointers are actually just object classes. So yeah, this one, it doesn't really make a much difference. It's just a string. All right, I see a few people still typing. Yeah, so the Maven example, I haven't pushed it yet, but I'll push this to GitHub soon. Okay, so the next question, so using foreign specifier in regards to extend or implement another class. Yeah, that's the plan. Basically making use of foreign specifier to somehow specify this module extends some Java class or it implements another class. So that's the direction I'm also looking forward to. Yeah, so the implication is basically you would see, for example, this main, so this make applicative class, for example, no, that's not a good example, but if you have some modules, you can basically specify some kind of foreign specifier so that this module extends some Java class. So yeah, that's definitely in plans, and hopefully we can support it soon. And similarly, using the foreign specifier to specify Java annotations as well, so that you can annotate the classes, or even you can annotate methods or even parameters, right? That would be useful for integrating into existing Java frameworks. So yeah, that's definitely in plans as well. And the next question, what kind of contributions can the community participate in? At this moment, any help is appreciated, but creating a Maven or Gradle plugin would be very helpful, because most of the Java projects are using heavily either Maven or Gradle. So those plugins, it shouldn't take much. Yeah, with JVM backend, maybe it's a bit easier. So that would be definitely helpful. And also optimizing the compiler. I know that's a lot of work, and I'm also looking to see how we can optimize even the bytecode, right? Currently, it does a very basic transformation, but we can also add some other compiler optimizations. Like one thing I mentioned in the beginning, instead of using lookup switch, we can use a table switch in the bytecode, and also optimizing these switch statements, right? This doesn't really require a switch. It can be simply an if. So those kind of small things we can definitely optimize, which would be hugely beneficial. And then yeah, native image for compiler, that's another thing I wanted to mention. So that would be hugely helpful as well. So rather than asking users to have a JVM installed, if we can compile native image, or if we can package Idris compiler along with the JVM, that would be very helpful as well. So I think those are the areas that we can immediately benefit from, And then of course there are a lot of other goals, like bigger goals like IDE support, which is a long way to go. We can even maybe compile to Java 11 soon, because a lot of projects are now moving to Java 11. So yeah, so the exporting definitions. Yeah, so that's what yeah, that's the next question in the chat, how we can export definitions. So that's another thing. It's related to extending classes or implementing another interface. Basically, you want to export Idris module so that we can call from Java. Idris 1 had a mechanism where it made a bit easier to do these kind of things. I haven't closely followed up with foreign in Idris 2. I don't know whether there is a mechanism, but probably using foreign directive to export definitions. Yeah, so that would be one way. But yeah, that's also currently in plans. But it's not currently supported. I mean, you can of course call these methods, right? These are just regular Java methods. But yeah, it would be a bit nicer if we can export these kind of functions in a more Java friendly way. All right, any more questions? Please post your questions on the chat. Yeah, so interrupt with Scala. The thing is, in the bytecode, you almost don't have all the types, right? What you see in Scala code, Scala is much more expressive than Java, but when it compiled to Java code, it's just basic types, right? So you don't really need to have like proper types in the bytecode level. It would also be extremely difficult because the type systems are vastly different. Yeah, somewhat closer to Scala than Java, but still I think since JVM itself, it doesn't really care about the generic code. It just has few functions and types are actually erased. So it makes it a bit easier for these new languages to be compiled to JVM. But yeah, with as I mentioned, with Idris 1 JVM backend, you can actually export precise types with Idris 1 foreign mechanism. So hopefully we can have something like that in Idris 2 backend, and Idris 2 JVM can then compile to that. But until then, I think it's kind of an open question how those definitions would be compiled. Oh, another thing I wanted to mention, I actually forgot. It does, the JVM backend does generate debug symbols. So hopefully when we get IDE support, maybe we can debug line by line with Idris source code. It's still not perfect, but it does add debug information to the bytecode. So you have Idris file names and Idris line numbers actually in the bytecode itself. So we can probably debug enhancing that mechanism. So as you see, let me show one such example. So you see these ones, A, B, these are all actually variable names from Idris source code. So wherever we can get source code information from Idris, the bytecode actually compiles to them. Yeah, you see here this func. This also comes from Idris source code. So it does add debug information to the bytecode. So maybe one day we can have debug support in IDEs. Yeah, so the next question in the chat, issues documenting what's missing in order to implement the debugging interface. I haven't looked much deeper into the debugging itself, but in some cases the source file name is missing, and then so basically the way it works, it gets the source information from expression, right? As it compiles to bytecode, it gets the source information from the expression. In Idris intermediate code, there is a class, there is a type FC which contains the useful information. So it makes use of that to figure out the line number. It doesn't always correspond to the right code, which is what I have noticed. But most of the times it's perfect. So like you see here, these variables, they come from Idris source code. So I haven't looked much deeper into this, but maybe yeah, I can document. That's a good idea. I can document what's required or what's missing from proper debugging. Yeah, as for compiling only the used functions, it basically builds a tree of functions from the main function, and then it compiles only those functions. So that's why you see, if you have a big module, then you would see a lot more classes getting compiled. But if you have like a hello world example, it's going to compile to very few classes with just primitive functions. So it basically builds a tree from Idris main function.
Is the microphone working now?
Yeah, I can hear you. It's actually much better. Yeah.
Cool. Okay, so thanks for the presentation. I think it's really promising what you have here, especially given the amount of code that is already out there that is using anything on the JVM.
Yeah.
It would be great if we could figure out this import and export mechanism so that you can write boring code in Java and then verified code in Idris,
Yep.
and then just import the Idris function.
Yeah, I haven't looked into far in much deeper recently. I don't know whether there is a mechanism that we are working out currently in the Idris itself. But yeah, we will figure something out hopefully sooner.
Yep. All right. So if there are no more questions, maybe you could plug how. So if someone wants to help or contribute or talk to you, how can they communicate with you?
Yeah, so the GitHub repository, please open an issue or even Discord. I try to be active on Discord, so you can reach out to me on Discord itself or any way possible. So I'm open to suggestions, improvements, and yeah, even pull requests. So currently, yeah, this is the source code repository. Yeah, I haven't released 0.4 yet, but yeah, I'll be releasing 0.4, and then hopefully with 0.5 we can catch up to Idris default backend, and then we can work on all these improvements after that. So yeah, any kind of pull requests or anyone wants to reach out to me, that's perfectly fine.
Great. Thanks a lot. I'm gonna go now. I guess we can talk to you on Discord.
Yeah, yeah,
And
I'm
thanks for
available.
coming. It was very, very great.
Yeah, thank you everyone.
Please, please tell us if and when you upload this, and everyone congratulate Mari for this amazing work. I think it's very well deserved.
Yeah, thank you everyone. I'll upload the video. Hopefully I record it fine. So yeah, I'll upload the video and then post a note on Discord. Thank you
All
everyone.
right.
Have a great
Thank you very
weekend.
much. Bye.
Bye.